I will tell you that my boss there, Mr. Abel, for many, many, many years said you can't do a nuclear panel. No nuclear panels, right?
In California.
In California, yeah. And this year I said, David, can we talk nuclear? He said, yes. It's finally time. We can talk nuclear. It's been quite a journey, right? And I think, a long period of silence and even scorn after 3 Mile Island, Chernobyl, and Fukushima. Now we're starting to hear a lot about the promise of new nuclear, right? Nuclear that can help us decarbonize, it can supply new energy demands from AI, EVs, and more. New nuclear, that's the term they use is walk-away safe. It's modular, it's standardized, it's cost-effective. We also hear about a whole bunch of firms that we didn't hear of before that are chasing this dream, right? Firms like Oklo, X-Energy, TerraPower, Holtec, they've been around for a long time, but most of them are newer firms that have emerged into the marketplace. And environmentalists are jumping on board, which is funny for me having lived through the whole era of nuclear, that the environmental guys are saying, yeah, we want nuclear. I said, but you hated nuclear. Well, not anymore, right? And because the world has changed. And, the promise was always abundant clean energy from nuclear, but we knew it had a lot of hair on it. And now I think we have technology that makes people believe we can do it without the problems and really capture the benefits of nuclear power. So our question really today in this panel is, so what's the truth? Is new nuclear really ready or nearly ready for commercial deployment? How safe, how much, how fast, what does it cost? Who will buy it? Who will own it? What happens to the waste? These are questions that are before us right now that have to be determined, and our panelists will help us learn where we really are today and what the future might hold. And we have a great panel. Starting at the end there, my friend Arnab Pal, who senior advisor and consultant to the U.S. Department of Energy, now doing consulting and investing in the energy space, and really smart guy, and delighted he could join us. And immediately to his right, we have Anssi Paalanen, and I probably misspelled or mispronounced her name, right? Of course, but I did the best I could. He's from Finland, and I don't speak Finnish, so Anssi has worked, he's with the Finland National Emergency Supply Agency, NESA. He's worked in a wide range of positions in the Finnish energy industry: nuclear safety analysis, severe accident management, renewable power, operational risk management, and so forth. So a long career, and you're going to hear a different perspective about what's going on in Finland compared to what we've had here. And then finally, last but not least, Singh, who's the nuclear and small modular nuclear reactor lead for Stantec, global engineering firm. And Jag has extensive global experience in nuclear energy, renewable, oil and gas sectors. Big, long resume like all three of these gentlemen, but you're going to learn more about them. So we're going to ask each of them to provide some comments on the state of new nuclear, where we really are and what challenges are, and sort of what we're seeing ahead of us. And then we'll let y'all ask questions. So who wants to go first? It's panelist choice.
I'll go first.
You're not shy, Arnab. I know that.
I think they'll do more of the talking, so I'll go first.
So,
my background in this is really the 2.5 years I spent at the Loan Programs Office, where we were able to put out both the Vogtle Unit 3 loan, and also be able to put out the Palisades Restart, among many other loans that are in the pipeline. I think I'll say a couple things to get the conversation started. When you think about nuclear, it's not a competition with the other renewables out there. It is a both and, not either or. And I'm going to cite some things from our nuclear liftoff report. One is the study that showed what power costs would be in California in 2045. So if you're looking at renewables and storage in terms of costs, you're looking at about $129 to $150 per megawatt. Renewables with storage and nuclear, $80 to $94 a megawatt. So you're talking about 37% reduction. Now that is by 2045, and we'll talk about the immediate versus the future. But as we're framing this conversation, I do think we want to look at it as complementary to the other renewable sources out there.
Indeed. Yeah, well, that was short, but good. Thank you.
Yeah. Well, I mean, I could say more, but I want everyone else to.
Yep.
Yeah.
And you will.
Yeah.
Anssi, you want to go next?
Yeah, thank you. Maybe I'll start first, just a couple of words, what's Finland? So Finland is a Northern European country. No, that's a quite different topic, fortunately. So it's a Northern European country between Sweden and Russia. We have 800 miles border with Russia, 5.5 million people, high standard of living, very energy intensive industry. We have forestry and metals and so forth, and wind, nuclear, hydro are the biggest electricity sources. We have a lot of district heating in Finland, so that's Finland in a nutshell. We are also very quiet. We are also very stubborn. We don't like to talk. So then about a couple of words about Finland and nuclear. So we have five reactors. The latest one actually just came along 2 years ago, Olkiluoto 3. I consider Finnish nuclear as a success story in many ways, and many things contribute to that. We have a very high our own skill set. We have a very market-driven way to generate nuclear. We have a skilled regulator, and power companies have active dialogue with our regulator. And we have our waste solution existing, so we have kind of worked that from the 70s. And acceptability of nuclear is very high, so all those contribute are byproducts of a success of nuclear in Finland. But if you consider a new nuclear in Finland, those are needed, but we need more. First of all, regulation is very outdated. It's very much geared towards these huge old nuclear plants. So we have to, and we are updating our regulation. I think every country that is considering SMRs, small modular reactors, they have to really reconsider the regulation. Otherwise, the old regulation won't work. And then our electricity markets are. We have in Northern Europe we have day-ahead markets, basically, and energy only markets, meaning that basically electricity cost is based on the supply and demand on hourly level, and it's stated 24 hours beforehand. So it's very much dependent on what's the current wind situation in Nordics, very much, and that's not very compatible to our new nuclear generation. And that gets us, I mean, we will talk a lot about renewables. Renewables are here today, and in any market that we are having, it's a fact that the cheapest way to generate electricity in any given market, it's renewables. If you just look in the amount of megawatt hours, it's wind up north, it's solar down south, so it's nuclear as such. If you just compare megawatt hours, it's not going to be competitive. Of course, if you include into that equation that you need to have electricity in a certain time, then it's a different story. And then it's a question how much and how will the potential customers, how much they value the certainty of their electricity. And that means that we have to consider our market solution, current market solutions, market structures, to think whether we are actually ready to have new nuclear, whether our current market structure is actually suitable for 100% or 80% or 50%, for example, wind power or solar power. So currently we have a very low electricity prices in Finland, something like $0.10 per kilowatt hour in average, but we are also the most volatile electricity prices in the whole Europe. So if you have a business that's very energy intensive, that's of course extremely difficult, because then you have a widely fluctuating electricity prices. So and especially if you have a very high level of renewables, then that volatility is going to just grow. So some sort of a baseload power is really going to help there. And the question is just what kind of market model would be suitable for having nuclear, or maybe to having a decarbonized electricity system that is reliable, that is affordable, that is clean, and is resilient. Especially in Finland and other Eastern European countries located next to Russia, the resilience of the electricity system, the resilience of the society is extremely important. So the question is how we can value the capability of generating electricity even in a situation where that isn't needed. Do we have some sort of capacity markets? Is bilateral solutions or contracts enough? But the current energy-only market is not good enough. And that gets us to a question of what kind of nuclear power plant could be successful in any market, basically. So we have heard a lot about there's almost 100 new small modular reactor designs. Some are old, some are new. Many of them are extremely exotic. From my point of view, you actually have to extremely simple solutions. So simplicity is the key. So more simple your solution is, more conventional your solution is, more likely it's going to be a winner. So if you have a simple solution, then it's predictable. It's predictable from regulation point of view. You make the regulators work actually much easier. Then you have a lower capex risk. It also means that probably your OPEX during the lifetime of the reactor is lower, and especially the risk in OPEX hikes lower because you have a very simple solution. And again, from resilience point of view, it's easier to handle if you have a very simple solution. You can have a variety of supply chain options for spare parts and so on. And I really like to hear advertise the Finnish reactor design, district heated design, which is kind of a simplicity in a nutshell. So it's a light water reactor, very low temperature, very low pressure, just generates heat for district heating or desalination purposes. So that's kind of a solution that we should look into. So it's extremely simple solutions. From my point of view, those are the winners. And I have to say that Arnab, you take one of my comments, so I fully agree that nuclear and renewables, they are not enemies. I've seen it from both sides, both from renewable world and from nuclear world, that they tend to treat the other as an enemy, whereas they should treat them as kind of a complementary source or competition or something. Definitely not an enemy. Thank you. That's mine.
Awesome. Thank you. Jag.
Right, well, thank you very much, and I'll keep this short as well, as short as I can do, on the topic of nuclear energy. It's a hot topic, no pun intended, right? So there's usually three questions I always get asked when we talk about nuclear energy. The first is safety. Are they safe? We keep hearing about these incidents that's happened, many moons ago, some in recent memory. What do we do with the waste, right? We all are aware of nuclear waste. What do we do with it? And then we've got the cost. We know nuclear plants can be expensive. I mean, Hinkley Point C in the United Kingdom, we're up at $32 billion. Expensive. I think Vogel got up to about 12.5 billion, I think, something like that, right? I think it's a pretty expensive build. So what do we do about the cost? So I'll approach them one by one, but first we'll talk about readiness. So one of the questions you were asking, right, Jim, was where are we? We're on our finger on the pulse right now. Where are we with nuclear energy and SMR? So in Canada, last week we had the license to construct issued by the CNSC for the BWX300G Hitachi reactor at Darlington. So this will likely be the first small modular nuclear reactor deployed in North America. There are others in the world, but in the Western Hemisphere, let's put it that way. So that's likely to be the first one, built and operated all before 2030. That's the plan. Okay. The Natrium reactor, Bill Gates' TerraPower. They've broken ground and they've got their permit filed with the US NRC as well. So it's moving ahead. X-Energy, it's all over the news right now. We have their construction permit's been filed with the US NRC, and any of you that are paying attention to the news will see they've got an extremely large backing from the tech industry, being Amazon. So $700 million was for funding for the development of that advanced SMR. It's hugely important because it shows you the tech companies and tech industry's sentiment towards stable baseload clean energy generation. It's really important. I get quite a few calls through Stantec One of them is from our mission critical group, which is data centers and AI. And I asked, so what's the power demand of one of these data centers? And they said, look at about a gigawatt. A gigawatt. Right. So Alberta, where I live, they want to become North America's center for tech, specifically Canada's center for tech. Obviously, I don't think it'll compete with Silicon Valley. So if they want to bring that onto the grid, that's not going to be feasible. We're on rolling blackouts as the last year. So such is the power of demand. So the tech industry is really behind this now. We're seeing Microsoft restarting 3 Mile Island, right? One of the units of 3 Mile Island. So if the tech companies are behind it, industry sentiment's behind it, it's moving forward. And the latest big development is NuScale is intended to have their design approved by the US NRC in July as well. So it's all moving ahead. There's various reactor technology firms out there that are plowing ahead, and we're seeing that sentiment across the world now. At COP28, there was a promise to triple nuclear energy by 2050. So that is a significant amount of global backing behind nuclear energy. And I like what you said there, how you started it. You know, I've got an offshore oil and gas background as well, and mining, and I'm never team A, team B, or team C. We need all of it, and we need it as quick as possible, because population growth, industry growth, technology growth, at some point, it will become an issue of national security if we can't get ahead of this, right? You know, it's going to become seriously problematic for us if we cannot keep up with the demands. So moving on to the topic of safety, what we're seeing now in some of these advanced reactors is walk-away safe. You used the term perfectly there. We keep hearing about walk-away safe. What does that mean? On a conventional nuclear power plant, you have to activate shutdown rods, right? You have to have operator intervention on conventional nuclear plants. Some of these advanced small modular nuclear reactors, actually, they have passive safety systems. They have technology, innovation, like a negative void coefficient. And I don't want to get too technical here on a end of day panel here, but what it essentially means is the hotter the reactor gets, the less reactive it gets. So it's self-shutting down. You can no longer have nuclear meltdowns on some of these technologies. We also have passive cooling systems. So as before, you need an operator intervention. I need to activate a shutdown system. They have passive cooling, so you don't really need to do anything. The reactor can take care of itself. It cools itself down. So there's no need for complex, crazy systems that have such a high degree of reliance. That's what drives nuclear plants to be expensive, is the levels and degree of depth of substantiation that we need on safety systems. So as we start moving away and start eradicating some of those, then plants inevitably become cheaper and cheaper and cheaper, right? So it's a significant development, as is the fuel. So that's just the reactor itself, but now we're seeing innovation in the fuel itself, right? So typically, conventional fuel, you'd have ceramic pellets with uranium in there. But now we're getting fuel innovation. So we get trisol particles in the X-energy reactor, and the trisol fuel is actually a sphere, a ceramic sphere that contains the nuclear fuel. So the intent and the purpose is, as nuclear fission happens, and we split the atoms and we get the really radioactive material as the atoms split, it's contained within the sphere. And that is qualified for extreme temperatures, which means it will contain that radioactive, dangerous waste within that sphere. Okay? So again, innovation across the patch, and it's going, and it's moving at light speed right now. So the next bit is cost. The cost element of it is something, you know, it's a hard pill to swallow for a lot of companies that come to Stantec, and I jump on a call with them and they're saying, oh, we want an SMR. You know, in one case it was a farmer, right, down in the US, right? A farmer said, I'm thinking about an SMR as, you know, yeah, the price tag and the capex on one of these things, you know, hey, it's upwards of $1 billion. And you see everyone's face just kind of drop, right? But that's the first of a kind. And the whole point behind SMRs and small modular nuclear reactors is the first of a kind may be $1 billion. But the whole point of modularization is the idea, the ethos, the spirit behind it is you do mass fabrication, roll it off as you would as a car on a manufacturing line, do your off-site testing, your off-site build-out, do your works acceptance testing, qualification off-site. And what that does is reduces the amount of stuff you have to do on-site, that's where it gets really expensive. And you modularize it, you modularize the build. You simplify the construction. And as we start getting efficiencies and enhanced manufacturing technologies, we get repeatability, right? You learn your lessons from your first of a kind. Your supply chain strengthens. They all know how to work together. They all know the process over time. You get economies of scale and material. You eventually get to a point where the nth of a kind becomes cheaper and cheaper and cheaper. The knowledge base gets better and better and better and bigger and bigger, and the whole supply chain becomes strong enough to support big rollouts of nuclear plants. So that's the intent behind small modular reactors, roll them out into industry in mass. The waste piece. The waste is another hot topic, no pun intended there, right? It's a topic where in the UK, where I'm from, born and raised, and I spent a lot of my career in the nuclear industry, we're still dealing with it. We have a good, strong nuclear decommissioning sector there. We decommission plants, we safely package material. The company I came from, Maltex, which is an SMR developer, they also had a sister plant, which was they take nuclear fuel, which 90% of uranium in a fuel pellet is actually unused. It's usable. They stripped away the 10% and recycled the rest. So now you're getting a recycling of nuclear fuels. In France, in Europe, in the UK, they use the Purex process to reprocess fuel. So innovation, once again, is coming out very, very strong. We really need to start looking at ways to reduce the amount of fuel. And if you actually look at how much nuclear fuel the entire US fleet has produced in last 60 years, I think the infographic shows it as a football field of nuclear waste at 10 yards. All that power, all that energy. It's really, really important. And we do need to, be custodians of the world. So we have to be responsible. And we are, and I can proudly say, we are one of the only energy industries that take full accountability for the entire nuclear waste cycle early in design, right? We cost it into our decommissioning plans. We plan for it in our early design. It goes as part of our license applications right? So, what better example of custodianship is that? We have to have a plan on how we safely decommission it and what we do with the waste. And there's all sorts of ideas from long-term stores, the DGR in Canada's going ahead. Finland, I believe across in the Nordic areas, you've successfully handled storage of waste. And it's, the innovation will come through once again. We'll find a way to recycle that waste and make the best use and safely, and I can't emphasize this enough, safely ensure that the remaining high-level nuclear waste is stored long-term. Okay.
Awesome, that was great. Well, now I've got a few questions, but I'm going to turn it over to all of you first. Questions for our panelists?
Thank you for the presentation, wonderful information. So, I have a couple of questions. One is really around PR. The number of people who have suffered health problems because of coal-fired plants probably far exceeds, other than, you can keep Fukushima aside for a moment. You look at North America and Europe, people have suffered far more from fossil plants than they have from nuclear power. But the industry hasn't done a good job of promoting that image. And I wonder if you had any comments on that. The second question I have is around liability. I understand for the large plants like the Rivers and the Westinghouse or whatever it's called now, that it's an Indian company, the AP1000, they require the release of liability after a certain period of time where the manufacturer is not responsible. And That's the requirement pretty much the world over.
Mm.
I don't think other industries have that kind of requirement. And I think that has slowed down the growth of nuclear in new markets. I just wondered if you had comments on either of those factors.
Sure. Yeah, I can take this one. So the first one, it's the nuclear industry, and the reason why is if you have an incident on a nuclear site, it's a global event, right? In my days in offshore oil and gas, I couldn't believe some of the things that were going on, right, in industry, right? It's some of the shortcuts and some of the risks that were taken. But in the nuclear industry, you know, we have a very serious situation if there's a nuclear event, because it is a global event potentially, right? So when Chernobyl happened, the radiation clouds traveled across Europe, right? And it came right across the UK, and it was it can affect the entire world. So that's why the seriousness of it is so serious, you know. You know, I don't want to lighten the issues around, let's say, an oil platform. You know, if an incident happens there, it's a bad day. You have an environmental spill out, and you can have deaths, mortalities. But the nuclear industry has just such far-reaching industry like issues if something goes wrong. So the industry has been reaching out, and we've seen a lot of backing again. So communities, for example, I live in Alberta, which is an oil capital, you know, and everyone I talk to there in the local communities are pro-nuclear, believe it or not. Because what the realization has come down to is a very simple one, which is we're no longer using Cold War era technology, right? We're no longer, you know, the innovation that's going through, especially with SMRs, they understand it. There's good outreach. Utilities do a great job in Canada as well, and the UK. There's a lot of public engagement, a lot of early education, and a lot of community engagement to make sure that everybody understands that simple message, which is we are the safest industry in the world when it comes to energy, when you take into account the amount of energy units that has been generated, right? Even taking account the disasters that happened at Chernobyl, Fukushima, the actual mortality rates, if you look at the actual ratios, the actual mortality rates per unit of power that's been generated is like 0.01. It's very, very, very small. You know, I think there's, what was it, a total of 30 deaths direct, something around that number, even accounting for those disasters, direct mortality. So it all starts with early education, community engagement, and the industry can always do better, and we should do better, but at least it's now in the right, you know, it's in the right circles, we're at the right levels. You know, we've got federal government, US DOE, we're very pro-nuclear as well. I mean, they've got grants still available for nuclear technologies. And even at state levels, you know, the amount of states in the United States are reaching out to us, as well as provinces in Canada, to talk nuclear is very, very high. So there's a lot of them. And the second question on liabilities, in Canada, it's a little bit different actually. So the utilities we talk to out there, they actually have the insurances, so they're like billions of dollars of insurances. So they take the liability, the utilities will take the liabilities out there in Canada. I'm still not sure how it works out here in the US. I still think the liability still lies with the site license holder, so I can't really speak to that. You know, I don't know if either of you have any inputs on that or any ideas, but with the US, you know, they're gonna get built regardless. Someone will take on the liabilities when they understand just the benefits of nuclear, right? So,
I'm going to jump in here. I think, you know, I think we need to think a little bit more recency with nuclear. I actually don't think like the threat of safety is actually the biggest barrier. I think that's a thought process from 10, 20, 30 years ago. The latest approval rating for nuclear is 56% in the United States. Getting 56% of the people in this country to agree on anything is pretty hard nowadays. So I would say that's pretty good. I think, you know, our research when I was at DOE is the biggest barrier right now is actually getting the investor and the purchaser, the utility, to get on board. And that's mainly drawn by the fear of cost overrun. And you brought up Vogtle. I think it's important to talk about Vogtle. So Vogtle was $15,000 per kilowatt was the cost, which is highly expensive. Right now, solar in Los Angeles to install, I think, is around $1,600 a kilowatt. But we need to take this into perspective. So our research showed that about 40% of the cost of the Vogtle plant was due to first-of-a-kind costs, which is what the DOE Loan Programs Office does. It puts the first thing out there to lower the cost. And due to overruns from Vogtle itself because of lack of know-how from not putting out that many nuclear plants. So I want to put this in perspective. Back in 2008, the cost of solar was around $10,000 to $12,000 per kilowatt, right? And in 15 years, it's gone down to about $1,500. The reason why I say that is because back in 2009, what the DOE Loan Programs Office was doing was first-of-a-kind solar, right? And it took us 15 years to drive down that cost. Now, our research shows that the next two plants are going to be half the price of Vogtle, right? So the issue that we saw in trying to build this marketplace is fear. Fear from the utilities, fear from the investor. One way that we have tried to bridge that gap is to say there is so much demand, especially from the data center AI folks who want nuclear, but they don't want to be in the power business. They are not going to do a behind the meter SMR. That's not even in question. Is to create a tariff, not the tariffs we've been talking about, a utility tariff, which is saying, anyone who wants to procure nuclear power at, X dollars a megawatt hour, generally over whatever the price point is of other power, can do so. And if you fulfill that tariff, if Microsoft, Amazon says we need $4 billion of power, and we will pledge to purchase this power at this price point over the next 10 years, that now brings the investors off the sidelines. Is we know we can build this because it's going to get built and we have the money for it. So I think a lot of the issue here isn't so much the fear of nuclear, it's fixing this marketplace and getting people to believe that the first of a kind is actually going to be modularized or run of the mill for the next 25, 50 to 100. And I think that's the challenge we're trying to overcome.
If I may continue. Kind of combining these two topics that you gentlemen discussed. So I think the cost overruns and risk of cost overruns, a combination of regulation risks. So, and of course, as you Jack mentioned, mass production is the key. So you have to produce not one, but 10 or 100 reactors. But then you have to be sure that the regulation is more or less the same in reactor 1 and reactor 10, so that you don't kind of have 10 different sets of regulation for each. And another thing in mass production is that you have to kind of squeeze a nuclear part of your production as small as possible, so that your mass-produced plant is as conventional as possible. So you use normal, good, high-quality industrial components and industrial solutions instead of having just a huge amount of very expensive mass-produced reactors. So really just ensure that the reactor and basically nothing else is nuclear and everything else is conventional power plant technology. That's easier said than done, obviously.
And it's helpful if we decide to choose the same reactor models and replicate those instead of trying to do 18 different reactor types, which is one thing we've also learned here.
Yes.
I have a question regarding the title here. New nuclear, is it real? Thorium, is it considered new nuclear and is it real?
The answer simply is yes, it is, because I don't know who else has been paying attention to the news about China's thorium reserves that they've just found, and they're producing a thorium reactor right now as well, right? So the answer is yes, it is. And thorium is a breeder reactor, right? So again, I don't want to get too technical on the end of a panel on a Monday when you got alcohol just outside that door. But yeah, thorium reactors, they're a breeder reactor, which essentially means you're breeding plutonium. You're bleeding more fissile material, right? So they are real and they're in development, and it's like a lot of different fast neutron reactors as well. They've been prototypes. The one thing I find a little bit amusing sometimes is SMRs is going through this renaissance right now. Everyone's talking about this new. We've had SMRs since Nautilus, right? I mean, in the back of a nuclear submarine, that's an SMR at the end of the day, right? And some of these Gen 4 reactors that we're talking about right now as well, we've had prototypes of those back in the 80s. So in Doon Reign, the UK, they had a fast reactor as well. So the technology's there. It's actually real. We've had prototypes running on some of these things. So.
And it's one thing to know, because when I was starting working on this stuff, I just think everything large is old and everything small is new, and it's not exactly the case, right? So, for anyone who's more of a nuclear neophyte, it's like, these Gen 3 reactors, which are larger ones, are state of the art and up to par as well. This really comes down to cost versus investment. The larger reactors are cheaper, like per kW, but it's $12 billion for one of them. Whereas a small reactor, maybe $1 billion, $2 billion, $4 billion. So going back to what I was saying earlier, to get someone to put the money down, to get customers willing to buy, it's a lot easier at a smaller investment cost. So with small modular, it's not just about the technology; it's the feasibility from a financial perspective.
It's funny. I asked Admiral Dennis McGinn, who many of you know, who's appeared at many, retired Secretary of the Navy, nuclear guy. Just this past week, I was talking to him, and I asked him about the nuclear Navy. And you think about, you knew this, but the nuclear power plant on a nuclear submarine, incredibly small, 125 to 200 megawatts from that little tiny nuclear power plant. And he told me a story I promised him I'd share with this audience, where he said, well, we had nuclear power in Hawaii. I said, no, there's no nuclear power in Hawaii. He says, well, actually, there was a hurricane, and it wiped out all the power generation on the island of Kauai. And he said, so I had our guys pull a nuclear sub up to the port and plug it in, and we powered Kauai for 4 months with this little tiny reactor. Amazing, right? So. Next question. We had other hands. I think you were first.
Yes. My question is about the sweet spot or the power output of these reactors. I read it's in the range of 100 to 500 megawatts. If this is the case, in terms of the best strategy for deployment, are we looking at really a distributed power system, or are we looking more from a safety perspective, for example, as retrofitting decommissioned nuclear plants with several of these units to reach the same power output?
I have a simple answer.
Okay.
I think the answer is both, but I'm going to let him give the detailed one.
So point which I didn't get a chance to really touch on, the applications. I mean, it's insane. Just the applications. We go right from micro reactors, right? So 8 megawatt, 10 megawatt, right? I've been having some discussions with some of the oil sands companies. They were like, well, can we get one of those on a skid, pull it up, and power up the drilling operations? And I was like, I'm not sure the licensing is going to work like that, but it's a cool idea, right? So there's going to be all sorts of applications. So the micro reactors, if you're looking at some of them, they fit on the back of a semi, right? And they can go into remote areas, remote places, and you can deploy one of those there. SMRs typically go to 300 megawatt electric. And even within just that range there, you got the 100 to 300 megawatt electric range. We've got some that are applicable for steam generation. So, we talked about X Energy, the Seadrift project down in Texas. Industrial application, right? That's not grid. They're not using it for generation. They're using it for, and we're looking at ARC putting a reactor in the oil sands in Fort McMurray for steam, for the SAG-D, right? So there's a wide array of different applications. And then you've got terrestrial, which is one that's just been picked up by Texas A&M, the university down there, to develop. And they have, they have 400 megawatt electric, and that's a really unique one because you don't replace individual fuel elements, you replace the entire core. The entire core gets lifted out, right, and replaced with a new core. So it depends. It totally depends on the application. The applications can be anything in this day and age. It's no longer just suited to grid. To your point about refurbishing old plants, yeah, we're looking at a couple of those projects as well. We've had some discussions. We've got the infrastructure there, right, for a grid connection. We've got, power infrastructure there, switchyard, turbines. If you refurbish one of those and put a few SMRs down and get the site license, absolutely no reason why we can't do that. But everything really comes down to the safety case. Okay, so you can do that. And you mentioned Hawaii. I got an example as well. Puerto Rico. Do you know that Puerto Rico has a nuclear reactor? I didn't until my Puerto Rico colleague at Stantec told me. They went and built a nuclear reactor in Puerto Rico. The problem was it was on a fault line, right, in a seismically active area. So they had to abandon the project. They built the whole thing, but they could never switch it on. So they're the kind of considerations you've got to look out for when it comes to nuclear is maintainment of the confinement of radiological material. That's where it comes down to. So each site will have to have a feasibility assessment done on it, and then take it from there. If the site's suitable, there is absolutely no reason why you can't throw down a few SMRs, a couple of units of SMRs to power and connect to the grid.
I want a micro reactor for my iPhone. That'd be cool.
I'm working on it.
Work on that. Okay, Jag's got that covered.
Earlier in the discussion, you guys were talking about the problem with nuclear and the base load being needed to be very stable. Have you guys looked into the use of electrolysis for hydrogen as part of the load stabilization and perhaps one of the solutions for the green economy and zero carbon society that we're looking towards?
Yeah, I mean, that's being looked into. So that's many nuclear power companies are kind of looking whether that's feasible or not. I mean, from technology point of view, that's feasible, but whether you have you can cover the costs or whether high enough usability for both nuclear reactor and electrolyzer. So that's a different story. And
hybrid use case, hybrid business case, maybe.
yeah, so then it's down to cost. But I mean, from technology point of view, and there are actually this high temperature nuclear reactor concepts at least that kind of can directly produce hydrogen, but that's a different story.
Yeah, I think it's unlikely that you'll use a nuclear reactor to drive an electrolyzer to make hydrogen. There's just too many steps with too many costs along the way. I mean, typically you're going to use excess nighttime wind and off-peak solar to drive an electrolyzer because it's power you'd have to pay for and you have no use for. And that's how you'll get most of your green hydrogen, which we're going to require in California, I think. You had one.
Yeah, just a quick question. So I'm going to preface what I'm going to say. I'm a fan of nuclear. I've got some background in that, worked several nuclear projects. But, I've also done a lot of DoD work, Department of Defense work as well. And so as I hear these conversations, with SMRs and, we looked at one point, I worked for JPL, NASA's Jet Propulsion Lab for about 25 years. And one of the projects we looked at was, if you're familiar with radionuclide thermal electric generators, RTGs. So that's why they call them RTGs. It's easier to say. But at any rate, for downhole applications in deep wells in the Gulf of Mexico. And here's the point I'm attempting to make. So as you get more and more nuclear material out there, the energy barrier for how you defend that. I mean, if you go, to go out to a regular nuclear reactor right now and try to jump over the fence, there's going to be all sorts of people that are there talking to you. But as you go to smaller and smaller quantities, the threshold for security is going to go down. So I guess here's the question I'm posturing for in kind of a yakety way. To me, it's probably inevitable that at some point in time, somebody of nefarious nature is going to get a hold of this stuff and make a dirty ball of it. They're going to set this thing off in New York and make downtown Manhattan look, so to speak. So.
Finally get rid of the giants.
What's that?
We'll get rid of the giants, finally. We've been praying for a miracle for years.
The question I guess I'm putting on the table is in my mind, it's almost inevitable that at some point in time, that's probably going to happen. So as we, have this debate and conversation around SMRs or other, approaches to nuclear energy, is that factored into the conversation?
So-
something like that's gonna happen, and two, how do you mitigate it?
So I want to jump in here, right? So the HALEU, which is the reactive compound in SMRs, that is not weapons grade. So I think what you're saying, while I understand is would be a concern, like it would not be possible to make that from the HALEU that's put in those small modular reactors.
Yeah, so I really don't want to get arrested by the FBI here, and I don't want to get into nuclear weapons technology discussion. So I think the question is, a dirty bomb is where you're going with it, which is, you can just use any kind of radioactive material to essentially,
bomb.
yeah. And I'm really hoping not to get snagged outside this door now that I've said those words. But essentially, where we have those safeguards and security measures, and this is one of the things that's a little bit of annoyance to me, is you see these fancy renderings of SMRs now, right, with these tiny little things that will fit in. There's no way it's going to happen, because not only do you have federal regulation with the US NRC, in our case the CNSC in Canada, the ONR in the United Kingdom, but you also have the IAEA, right, which means every nuclear facility has a duty to safeguard nuclear material. We have to be accountable for all material that's on that site, and an IAEA inspector can come down at any time, whenever, day or night, any time of the year, and they can turn up onto a nuclear site and say, where's your inventory? And you have to be able to demonstrate to prove to where it is. So I don't think we're actually going to see a reduction in security measures. We can. The IAEA won't let it happen. And also the regulatory bodies in each country will not let it happen. You won't be able to really get a design built if it doesn't have security and safeguard measures. So whether that's security fencing, security with the guns, we're still going to have all of those. And in fact, when we were at Maltex, where we were an SMR developer, we were actually developing the technology. In our technical feasibility and economic feasibility studies that we were doing, we costed all that in because we knew there was no way around it. You're going to have it, because the risk, we talked about it a little earlier as well. Any nuclear incident will set back the countries, the world, by decades. It's just not affordable, and we can't have environmental risk. We just can't have. It's the crux of our industry. And again, it goes back to why our plants are so expensive. The defense in depth and the levels of substantiation that we need to have in our designs is what adds to the cost of the plants, but it's absolutely necessary. So I actually, even though I'm a cynic, I actually think it's the opposite. I'm very optimistic that SMRs, MMRs, any measure of this, if there's nuclear material there, it will be secure and it will be safeguarded.
Yeah, if
It's
I
hard
might continue.
to believe.
Just to add on that, so I feel the same way, that actually the small size simplicity may actually even improve the security and safeguard. So it's easier to guard. It's easier to underground your nuclear facility when it's a small. The power level is smaller, so the facility is smaller, so it's actually easier to safeguard nuclear material. And of course, they use nuclear for really nasty stuff to handle. So you just don't go and grab it, as you know. So